Quantum technology is no longer just a theory or something confined to physics labs. It is rapidly becoming a transformative force across computing, communication, sensing, and materials science. From solving problems that classical computers cannot, to enabling ultra-secure communication and highly precise measurements, quantum technology is poised to change everything. In this video, we will explore the most impactful quantum technologies, how they work, and why they matter for the future. At the core of these technologies are qubits, the quantum equivalent of classical bits. Qubits can exist in superposition, representing multiple states at once, and can be entangled with each other, creating correlations that defy classical explanation. These properties allow quantum devices to perform tasks that were once considered impossible, giving them a unique advantage over classical systems. One of the most visible applications is quantum computing. Unlike traditional computers, which process information sequentially, quantum computers can explore many possible solutions simultaneously. This enables them to tackle problems such as complex chemical simulations, optimization challenges, and large-scale data analysis far more efficiently. Industries like pharmaceuticals, finance, logistics, and materials science could be revolutionized by quantum computing. Imagine discovering new drugs by simulating molecular interactions in seconds rather than years. Or optimizing global supply chains in real time. These are the promises of quantum computing. Another major area is quantum communication. Using entanglement and quantum key distribution, information can be transmitted with unbreakable security. Any attempt to intercept a quantum message alters its state, immediately revealing the intrusion. Governments, banks, and corporations are investing in quantum communication networks to protect sensitive data, and satellite-based experiments are already demonstrating secure long-distance quantum links. Quantum sensing is another revolutionary technology. Quantum sensors exploit superposition and interference to measure quantities like time, gravity, magnetic fields, and acceleration with unprecedented precision. For example, atomic interferometers can detect tiny gravitational anomalies, improve navigation in GPS-denied environments, and even search for underground resources or hidden structures. These sensors will transform geophysics, defense, environmental monitoring, and space exploration. Quantum technology is also driving advances in materials and chemistry. Quantum simulations allow scientists to study the behavior of electrons in complex molecules and materials at a level impossible for classical computers. This opens the door to designing superconductors, new energy storage systems, and novel materials with properties tailored for specific applications. In essence, quantum technology lets us predict and engineer matter at its most fundamental level. Quantum cryptography, closely linked to quantum communication, will redefine security standards. It enables secure authentication, encrypted communication, and protection against attacks from future quantum computers that could break current encryption methods. In a world increasingly dependent on digital infrastructure, this is a critical advance for national security, commerce, and personal privacy. Hybrid approaches are also emerging, combining classical and quantum systems. Near-term quantum devices, often called NSQ computers, noisy intermediate-scale quantum computers, are already being used to enhance classical computations. Algorithms can exploit quantum properties for optimization, simulation, and machine learning, showing that even imperfect quantum hardware can deliver practical benefits today. Another exciting frontier is quantum networks and the quantum internet. These networks use entanglement to link quantum devices over long distances, enabling distributed quantum computing, secure communication, and coordinated sensing across the globe. A fully operational quantum internet could connect research labs, satellites, and computing centers, creating a network fundamentally different from anything classical technology can provide. The development of quantum hardware is also rapidly progressing. Superconducting qubits, trapped ions, photonic systems, and quantum dots each offer unique advantages, and engineers are constantly improving coherence times, gate fidelity, and connectivity. As hardware improves, so too will the range of applications, making quantum technology increasingly practical for industry and research. Quantum technology is already impacting space exploration. Quantum sensors and clocks enhance spacecraft navigation and timing, while entanglement experiments in orbit demonstrate the potential for global quantum communication. In the coming decades, quantum devices may be integral to interplanetary exploration, enabling communication and measurement systems far beyond current capabilities. In simple terms, quantum technology changes everything because it leverages the fundamental laws of nature in ways that classical technology cannot. It is not just faster or more efficient, it enables entirely new ways of computing, communicating, and sensing. Problems that once seemed intractable, from simulating molecules to securing global networks, are suddenly within reach. The convergence of quantum computing, communication, sensing, and materials design marks a new technological era. It is a shift as profound as the invention of the classical computer or the Internet. Industries, governments, and scientific research are preparing for a world where quantum technology will be a central driver of innovation, security, and discovery. Ultimately, quantum technology is more than a set of tools, it is a paradigm shift. By harnessing superposition, entanglement, and quantum interference, humanity can explore, create, and understand the world in ways previously unimaginable. The changes it will bring are only beginning to be realized, but the potential is extraordinary, and the quantum revolution is already underway.